Right, today then we're going to look at parallel circuits. We're going to look at the current in parallel circuits, and we're going to look at the potential difference in parallel circuits. Let's start then by looking at what a parallel circuit actually is. You already know what a series circuit is. In a series circuit there is only one route for the electricity to take. It can only flow down one route. Okay, the components are one after the other in series. In a parallel circuit that is not the case. In a parallel circuit there are more than one route for the electricity to take. In this particular example there are two routes for the electricity to take. There are two branches. You've got branch 1 with ammeter 1 on it, you've got branch 2 with ammeter 2 on it, and the electricity can flow either through branch 1 or branch 2. Okay, right, so the current then can flow through either branch 1 or branch 2. Let's think about how the current is going to behave. You know, in a series circuit the current is exactly the same everywhere, no matter where you measure it. Well, it's not the same in a parallel circuit. It changes based on where you measure it. So if I was to say I'm going to take a measurement here, okay, this is our total current. Okay, now let's say our total our current here, let's say I measure it there and I get let's say I get 2 amps. Okay, I get 2 amps of current in that one. Now if I then measure my current at ammeter 1 here, so down the first branch, then I might measure, let's say I measure 1 amp. Okay, so I've got 1 amp going through this way. Now the current has to be conserved, so exactly the same amount of current therefore has to pass through the second ammeter. Okay, so I'm going to get 1 amp through here as well, and notice that it's conserved here. So these two, ammeter 1 and ammeter 2, both add up to the total current through the first ammeter there. Okay, so 2 is going to split evenly down each branch. If I would then take another ammeter and I measure it here, okay, if I measure it here, now the current is not used up in this circuit. The electricity is still going to be flowing here, okay, but it's just going to be the current from this branch here, which we've just measured as 1 amp, plus the current from this branch here, which we've also measured as 1 amp. So this here is also therefore going to be it's going to be 2 amps, because it's going to add back together again back here. So these two here are the same. Okay, right, so let's see another situation. Now it doesn't always have to split evenly down each branch. Okay, the electricity doesn't have to evenly split down each branch. Let's say the current in this one was, let's say this is 3 amps here. Okay, now maybe this resistor, this ammeter measures 2 amps. If this ammeter measures 2 amps, then what is ammeter 2 going to measure? Remember what we said? These two have to add together to make the total resistance, the total current. So this is going to be 1 amp, and then they're going to add back together again here where they rejoin, and then this is going to be 3 amps again here, because the 2 and the 1 have joined back together to make a 3 amps of current there. So here's our current rule in a parallel circuit. So the total current, that is the current measured before it's split off anywhere, is going to equal the current down the first branch plus the current down the second branch, and if you've got a third or a fourth branch, then it's going to be all of the branches added together. Potential difference is a bit different. Okay, potential difference then is easier. So the potential difference is the same across each branch. Okay, so the same across each branch. Let's write that. Same across each branch. Okay, so it's going to be the same as the power supply. So if this power supply had 9 volts of potential difference, then the potential difference across this branch 1, is also going to be 9 volts. The potential difference across this branch will also be 9 volts. Okay, so it's the same across each branch. Right, if you wanted to work out the resistance along each branch, then you could just use the equation V equals IR, which we've looked at in a previous video. So you could just use V equals IR. You can rearrange it to get V divided by I. We know what V is because it's this 9 volts for this particular circuit. You know what I is because it, well, depending on which branch you're measuring the current of, it's either 2 amps or it's going to be 1 amp, and then you can figure out what R is from that. Okay. Right. There's a couple of follow-up questions down here I want you guys to have a look at. Have a go at them. I'm going to put the answers in the description below, and I'll see you in the next video.